Good afternoon, everyone. I'm Dr. Corinne Alexander from Purdue University, and I am filling in for Dr. Jess Lowenberg-DeBoer as session chair. I will also be giving his presentation. So welcome to the afternoon session where we're going to talk about assessment methods and metrics of post-harvest loss measurement. We have a few changes to the schedule, but it will all go very well because all the speakers are so organized. I'm very lucky. So it's my pleasure to introduce our keynote speaker. Our keynote speaker has 30 minutes total. If he finishes earlier in that 30 minutes, we'll be able to open it up for questions. And our first speaker is Dr. Bruno Tran. We're very lucky to have him from the Natural Resources Institute.
Good afternoon. So to introduce this session on metrics and measurements generally, I thought I would give you a quick overview of a selection of important papers and publications which have touched upon the importance and the quality of metrics and measurements on post-harvest losses. And then I will move on to telling you a little bit about AFLIS and how that relates to the debate, AFLIS being a producer of metrics. So what I will consider in this presentation, as I said, a selection of recent publications, all to do with the subject of measuring loss. I'll try to summarize what, in my view, we got from those publications. And then I'll move on to the case of AFLIS and how it relates to our community of practice as post-harvest loss specialists. So a little bit on metrics generally. And there is the good, the bad, and the ugly. So measurements, well, the Rolls-Royce of measurements will be direct measurement. So if you go into a store, you take a sample and you measure what the losses are on this sample. That will be the best. That's not always possible, so we have indirect measurements. And on this photo, I'm showing the example here, which the extension agent will have, and they will compare the example with what they take from the store, and by just visually comparing this and several other classes, they can determine very quickly, very rapidly, which type of loss they have. And then we have estimations. So that's a little bit further removed from the actual measurement, and especially direct measurements. And there is a whole variety of models that can be used for estimation. So we can use factors with mathematical functions to produce these estimations, and that can be extrapolation or just factor-based modelization. And another type of estimation is when we record the perception that people have of loss. So what it is that we are measuring, really? Well, I've got here an example of a value chain, and this has to do with grain, with cereals. And I would like to put to you that it is quite complex to measure losses across a value chain like this one, which has many links. And each link in itself can be difficult. And the example I would like to discuss a little bit is for one of these links, this one, farm storage. In the case of grain, that is one of the most well-studied links where we know a lot about which type of losses happen and how they do happen. But it still is much more complex than most of us would intuitively think, and that's why I would like to give you a little example here. Imagine that I am a wealthy farmer, wealthy in my village. So my harvest is about a ton and a half of maize. So just after harvest, I've harvested all this, and I've put it in the granaries that I use. And now I need a bit of money. I'm wealthy, so I've got 2 wives, about 10 children, and I need some cash. So I will sell 200 kilos immediately to raise some cash. Then within the first 2-3 months, my family, and I've also got my parents and some old relatives living with me, so we will consume maybe 80 kilos, 100 kilos per month. So we will retrieve that from the store gradually, but on average, say 80 kilos per month. After 3 months of storage, I will find that, unfortunately, one of my elder relatives has died, and I need to organize the burial. And for that, I need to invite everybody I know and lots of people I don't know, and I will need to retrieve another 200 kilos from my store, some to sell, to raise money, and others to feed all these people who will come help me celebrate the passing over of my relative. A few months later, I will need to pay school fees and buy books and uniforms. I will sell another 150 kilos, etc. Now, that's only what I retrieve from my store, and it happens piecemeal, one bit at a time, over time, during storage. So how do we assess losses on that? The first quantity I sold immediately at harvest, the losses were probably storage losses, 0, because there was no storage loss. The 80 kilo are removed after 1 month of storage. There was perhaps, say, 5% loss due to insects eating. Then the same 80 kilos are retrieved the month after, maybe 7% loss because the insects have bred and they keep eating. And maybe what I sold 3 months on because of the burial ceremony, that would have had almost 10% losses. What I sold because of the school fees, maybe that was reaching 14%. All that has to be put back into the context of how much I sold. So if you ask me now, what were the losses during storage, then it becomes much more difficult for me to tell you what was the percentage loss. And if I just tell you that was 14.7%, then I'd better be able to show you all the calculations I did on the small quantity that I kept 1 month, the larger quantity that was kept 2 months, the really bigger quantity that was kept 3 months, etc. So measuring loss is not that simple. And of course, as scientists, our resources are limited. If we send our technical guy in the field to do the measurement once during storage, then what are the chances that we get the right figure? If he goes or she goes the month after harvest, they will get a view of what the percentage loss is. If they go 6 months later, they will get a different view, but they will have very little idea about what's happened because of all the maize that is being sold during storage. And of course, the worst of it is if we send our technical person to the field 6 months after the end of storage, when farmers are beginning to prepare the next season, and ask the farmer, so last season, how much did you lose? Well, if you were a farmer, you would scratch your head and think, well, is that person going to give me some money if I tell him I'm very poor? Or will they give me a pickup if I'm telling him I'm a very good farmer? And then your response might be a little bit influenced by all that you think, and less influenced by what you remember that you lost during the last season, which in itself was very complex. So that's my way to say that measuring directly is very difficult. Therefore, we have to rely on estimates, but these estimates have to be thought through very carefully. Otherwise, we might get really the wrong picture. So let me now go back to these papers. Overall, all the papers, and I will show you the details in a second, will conclude that in terms of data, what we have is not enough. That's the most important thing. Overall, there is not that much data available, and very few are direct measurements, because that's very difficult, that's very costly. And even fewer which cover the whole value chain. A lot of the figures we have are based on perceptions, and that to me is a worry. So the first paper is from 2009, collaboration between FAO and the African Development Bank, and it was setting up a framework on the reduction of losses. It started with a desk study done by colleagues of mine from the Natural Resources Institute, and then they did what they call a situational analysis. So questionnaires sent to 8 countries and field missions where they recorded people's perception, again, in 6 countries. The overall results were they concluded that it is problematic to estimate losses by extrapolating from even specific, well-characterized loss situation. And that's because our survey techniques are not very accurate, and because it is very difficult to estimate because of the heterogeneity of the environment. They suggest as indicative figures the percentages that are appearing at the moment. So it goes from 10% on cereal grains and legumes, 20% for roots and tubers, 30% for fruit and veg, 27% for milk, meat, who knows, maybe 30%, fish, we know even less, 10, 40%, something in between. Second paper, the World Bank Missing Food Report. So that really kick-started a lot of the work we are doing now, or re-kick-started it. And that report started again with a desk study, with contributions from FAO, World Bank, and led by NRI. And it was interested in the magnitude and location of the losses, and realized, or confirmed, that they were poorly known and that most of the time there are only guesstimates. So not even estimates, but estimates, best guesses. Pointing to the future, that review said that we really need to better understand how big the problem is, so that we can use it in order to have interventions for food security and in order to design loss reduction interventions much better. It was calling for a collective effort to generate consensus on the methodology that we can use to measure losses. And it pointed out that we needed to be in a position to help national analysts to think of pH losses as key indicators of the efficiency of their national systems for post-harvest. And the last goal was to revitalize, and at the time it was very needed, but you can see that it is working very well, the community of practice that we have all together. Third paper by the Swedish Research Institute that was undertaken for Safe Food. In 2011, the Global Food Losses and Food Waste report. The headline, very simply, 1/3 of the food produced is lost or wasted. We've heard that this morning. This is a very nice headline. What we cannot do is go into the details and say, really, how we can justify the 1/3. It's guesstimate. This report used mass flow models to do this estimation, and these models use assumptions and allocation and conversion factors, which are based on assumptions. The loss figures were estimated from the FAO's food balance sheets, and these are, to simplify to the extreme, these are based on production figures and consumption figures. And what is missing in between, well, that's labeled loss. So that was the old way of guesstimating how much loss we have. Whatever is not on the balance sheet between production and consumption, that has to have been lost in between. And this is what these histograms are showing. They are showing 4 different parts of the world where the losses, in terms of balance sheets, are located. That's an example for sub-Saharan Africa, with different steps, links in the value chain, and the estimates of the percentage losses. And this is the type of model that is used to produce these estimates. So very mathematical, very simple in concept. It just adds the various type of losses at the various links in the value chain, and it's all based on this balance sheet approach. think it's the fourth paper now, a paper by Agra in 2013, which was about the status of pH losses and storage for major staples. This covered two phases. The first one was a literature survey on PHL, and the survey covered 11 countries in SSA, and it was about cereals, legumes, and roots and tubers. Then there was a phase two, which collated directly people's perception on losses. So they interviewed farmers and all the other actors in the food chain. So the result of that study, well, in terms of the literature survey, this is what they concluded from the available literature. Now, from a grains perspective, this looks really a lot worse than what I'm used to, but I imagine that for roots and tubers and veg, that might be the case. But they found that 95% of the papers they could access did not integrate the whole value chain approach. 40% had obsolete data. I'm not entirely sure how they defined obsolete, but that data that they judged to be too old. 83% were from grey literature, meaning they are very difficult for most of us to access. Overall, the data was deemed to be skewed towards a whole country rather than reflecting agroecological zones. There was no estimates that were linked to the cause of the losses, so mold, insects, breakage, whatever. And, of course, very poor documentation of the solutions that are being implemented. So quite a damning report here by Agra. Their second phase was about their interviews with actors in the food chain, where the conclusion, reinforcing everything we've seen so far, is that there are significant losses, and the losses occur all across the food chain. And some of the figures here are just reinforcing the usual guesstimates that we have. Paper number 5 or 6, I lost count. 2013, post-harvest losses in Africa, an analytical review and synthesis. Tells us that there are gaps, and they try to have an outlook on the future of research in our domain. The review was aiming at finding evidence for losses and also the magnitude of losses in 6 countries, and they wanted to understand the innovations which were being promoted and used to reduce those losses. This is a diagram showing how they did their literature survey. So again, that paper was based on literature survey. And this graph from their report is showing the number of papers they found. So for example, on rice, at the first screening, they had 28 papers. Yeah. Then they did a second screening and rejected some papers for low quality, and that reduced the number to 14. So 14 papers were used in their final report. And the report has a series of tables like this one, which gives you references and numbers for the losses, in percentage losses mostly. The FAO in 2013 has written the Development of Consistent Methodology report. It's a review of the current methods, and it started with techniques that were popularized and refined in the 1980s and 90s, like papers by Boxall and Compton, ex-NRI, and the most popular methods would be the count and weight or visual scales, very much like the photo I showed at the very beginning. Then the review goes on to review AFLIS, which I will talk a little bit more about in a minute. And finally, they collate some field results. Their framework for estimating PHLs is using a formula of this form, which is basically saying that the losses are estimated as a sum of all the losses that happen at each link in the value chain, something we've seen before. And that's the way they design the value chain. And for each step in the value chain, the links being here, they have a list of causes, and they suggest that the way we measure losses are related to the causes for each link in the chain. I think that's the last paper I will cite now, is one by IFPRI, very, very current, and it talks about the returns to investment in reducing post-harvest losses. And the idea is that they point out that the estimates of losses that we have vary dramatically across studies and across the type of losses that are being studied. The measurement of losses is problematic, and they conclude that it is critical that we develop better measurements of losses. So altogether, all these papers up to this year are pointing to the fact that we have some data, but not enough, and we can't be sure of all the data we have. We need better methodology, and we need better work together to do this measurement. So the conclusion for this paper overall, there are a lot of crops, a lot of countries, and a lot of different value chains. For each crop, we can have several different value chains. Each chain will fork. We like to design one value chain, but it never works like that. One value chain from the field will fork into several, and by the time you reach the consumer, you might have 10, 15 different value chains coming from one crop. The data we have is nowhere sufficient to give us the validity we need when we want to estimate losses. For the future, we need losses estimates that are largely based on direct measurement. Perception is good for some things, but not, in my view, to estimate losses. The measurements through perceptions are extremely important to design intervention. We need to know what is people's perception before we can work with them to reduce losses, for example. But in order to understand the losses, from a scientific viewpoint, I think that perception is not the best way to do it. We need a way of estimating the losses which is reliable, and by that I mean a methodology that is commonly well regarded, and that means that it is open and transparent, so that everybody can criticize it and make it better. And we need a methodology that is standardized, and I would refer to the keynote that is taking place in the other room at the moment on the WRI standard, which is setting the scene for a worldwide standard on how to measure loss and waste. And my conclusion will be that through AFLIS, we would like to offer one element of the solution, and that's what I will discuss in the next 2 minutes. So first, a presentation of what AFLIS has been and is up to now. So AFLIS is a system that displays loss estimates for 7 cereal crops by province for a selection of African countries. It uses an algorithm to generate these estimates from published data. So these will be scientific papers which have been peer-reviewed. That feeds into this algorithm. And from factors which are environmental and contextual, and these factors are fed into the system by a network of experts from these African countries. The method of calculation, so the core of the algorithm, is open, transparent, so everybody can look at it and criticize it. It is also very simple. It's very mechanistic. It works well, but it has limitations. And the output is in the form of either tables or maps, like this one, where you can see by country or by districts within the country, regions, the percentage loss, and you can also express that in quantities if you prefer, because the production values are used in the system. You can do that historically by checking different years. So that's the way AFLIS has evolved up to today. Now, the current data that is used, the scientific data that has been published, this is just to give you an idea of the number of papers that are being used to feed the scientific estimation of the losses. And we can see that there is an interesting peak there. So the papers produced after 2006 and up to 2010. Lots of papers. That's the revival of our field recently that has been discussed this morning. And 2011, 2014, we haven't got that many for the moment, but the work is ongoing, and I'm sure this bar of the histogram will grow very quickly. AFLIS Plus is what I really want to introduce to you now, and that's what we want to do from now on with AFLIS. The idea is that we would like to have a wider coverage, so seven cereal crops. We think that's not enough, so we will build on that and add more crops. And also, we don't want to limit ourselves to cereals. We want to go and touch on fruit and veg, roots and tubers. We will cover other countries. We'll start with 6 additional countries, but we hope to go further later. We want to improve the estimates, so the way the algorithm works and the data we use originally. So in AFLIS Plus, we want to develop new algorithms. Well, that will be required for fruit and veg and roots and tubers, which will need a totally different algorithm. But also for the cereal grains, we want to improve the algorithm. And we want to link the results, the estimates, with the risk warnings, for example, with the risk of aflatoxins, because we use weather data into the algorithm, into the model, so it makes sense to use that as an indicator of rain at harvest during drying, and that links directly to the risk of aflatoxin, for example. And we want better data collection. So we want to collect more data, better. So more data from grey literature, which at the moment does not hardly go into the system, but also data that will come from the field at a much smaller unit geographically. We want new partnerships. And that's the most important message for me, for AFLIS, and I'll stop after that. And these new partnerships is the reason why I wanted to tell you about AFLIS Plus now. We want to open the system to the international community, to all of you. We would like to integrate your knowledge, your skills, in the form of a steering committee of international experts, which will help us decide for the strategy for AFLIS Plus. We would like to use a technical board to help us decide which data should go into the system and how best to feed it into the system, and also to improve on the algorithms, the models we use to produce these estimates. And finally, but by no means the least, we want to connect better to the community, and we will do it. We are starting to do that, and the effects will come obvious very soon through the FAO community of practice. So that's the plan, that we will talk with you and listen to you much better through the FAO COP. So to conclude, in terms of AFLIS Plus, you're invited to join in. We have a stand in the exhibitor room where we would love to take your details and get in touch with you to build AFLIS Plus with you. Thank you very much.
We have 2 more minutes, so if anybody has a question, we could have a question for Bruno.
What is the fundamental problem with mass balance approach, production minus use?
The fundamental problem is that we have a very high-level figure which tells us nothing about the reason, the causes for the loss, and that makes our work into reducing the losses very, very difficult.
I'm Eric Luftman from the US State Department. With all of the challenges of gathering the data, and I can see how important it is, and yet is there a danger that we get so bogged down in trying to improve the data that policy efforts are delayed? And if you look sort of backwards in time, the most advanced agricultural economies have managed to get ahead and reduce their losses without having to study in detail, measuring the starting point and figuring out how they can reduce losses. They've just moved ahead through technological advancement. So, and we've heard, for example, the case of Rwanda moving ahead very rapidly. They had some very dramatic numbers for reduction of post-harvest loss in just a few years. But the important thing was policy change that led to that.
Thank you. Yes, I think the tools to improve already exist, mostly. The trick is to decide which one to use in which situation, and that's very difficult to decide without the right data. So that's why I think the data is really important, is within an environment where we have limited resources, deciding where to invest these resources is best done based on data. If we had less limited resources, a blanket investment would solve the problem. But the situation being that we have limited resources, I think we can help optimize their use by pointing to the right areas and the right solutions.
So this will need to be our last, one more question. Yes.
Yeah, Jethro Green from the Caribbean Farmers Network. The problem the little concern I have is that if the first world countries have advanced so much in reducing post-harvest losses, why are we, do we need to reinvent the wheel, or do we need to, because what I'm saying, if we are not careful, we boil down into academia rather than practical solutions at the farmer level. And my concern is that at the level that we are at, which is there theoretically, sound good, but practical terms filtering down to the farmer level require government's policy to invest in infrastructure, in the things that the first world country did. And what I'm saying is that while we need data and all these things to support that, a lot of it is common sense. When you go and you visit and you look at what they have done, it's just a simple matter of saying, what do we need to get our policymakers and our academia and our university to work together to do to address some of the problems? I mean, that's my main concern. And I'm more from the private sector farm organization level, and kind of a little frustrated with the fact that everything is stuck at that level, and it's the 500,000 farmers, millions of farmers down there. The small farmers, they are going deeper and deeper into poverty while we keep talking about all these theoretical solutions.
Thank you. Again, I think the answer I would give is very similar to the previous one. Given the limited resources we have, the best chances we have to use them in the right place at the right time is to have good data to help us make a right decision. It is true, I believe, like you, that the solutions are very simple. They are mostly common sense, but I'm sure you know that common sense is something that is very rare, and that is a very rare resource. Even common sense, we need to use it at the right place at the right time. So I do think data are useful, and this type of data will help us do the job better. I totally agree with you that where it needs to be done, and probably we agree also on the type of tools that needs to be used at that level. But this data should help do that better.
Let's thank Dr. Tran for